So welcome to math subject 93674 65. So 65 asks about complex analysis. So I usually, if you forget about complex analysis, then in the test you should try to come up with some examples. If you forget about the theorems like the Cauchy theorem and residue theorem and some holomorphic analytic continuation. If you forget about all of these, then at least you need to try to come up with some examples to help you solve the problem. So if f is a function defined by a complex power series expansion when z minus a with converge in z minus a smaller than 1 and diverge for z larger z minus a larger than 1, then which of the following must be true? Okay, so somehow you forget anything, so you try to come up with some example. So when I solve this, I think f of z. Okay, so maybe example is like f z defined to be at least 1. This is so simple that you should remember, right? This is 1 minus 1 over z when z is less than absolute value for z is less or equal to, less than 1, then diverge z larger than 1. And in this case, a is 0. Right, because z minus 0, z minus 0. So this function satisfies the property that the question 65 want to ask. Okay, so the A choice, f of z as analytic in an open unit disk with radius a. So how about f0? F0 is defined to 1, right? And f of z is 1 minus z. So this is 0, and f of z is 1 over 1 minus z. So this is well defined in a unit disk. So this is 1, right? In a unit disk of this is in this region. So if you can pick a small region disk, and in this case, in this region, f z is analytic. So A looks correct. Actually, we don't know whether it's correct or not, but at least it does not violate our knowledge. How about B? Say that power series for fz plus a converge when z plus a is smaller than 1. Okay, so and we choose a to be 0. So it asks about whether f of z converge for z smaller than 1. This is correct, right? But we just leave it. And the C say that f prime of a is 0. Fz is e1 minus z, right? So f prime of z is 1 minus z squared and 1. So when you plug f prime of 0, then you get 1. So it's non-zero. So C is wrong. Okay, so it's luckily we kill some choice. Integral is 0 for any circle in a plane. This makes no sense because this function only converge in a circle with radius a, and with 1 in a radius in a small region. So there's no way that the f of z is can be f of z is not defined everywhere in the complex plane. So when you say the integral of the complex for any circle in the complex, then this makes no sense. So D is wrong. D is wrong. Fz has a pole of order 1 as z equal to a. But we already show that f is analytically at we already know f of z. F of z. When z equals 0, then the answer is 1. So z equals 0 is not a pole. So E is wrong. So the only remaining choice is A and B. The only remaining choice is A and B. So there are the second way is we can come up with another example and try to rule out maybe A or B. But up to now, I think the answer is clear is A, right? So A is correct because the f of z is written as type of can be written as this type of form. So when when you have a power series close to A, then you also have non-vanishing radius of convergence. Then you can pick a small ball that here, that f of z is well defined. Because f of z is well defined, it converges in this region. So f of z is well defined at this region. So f of a will not blows up. And f of a has all the form of f of z only contains z. So that means f of z is at z equals a is holomorphic, because it defines on power series of z. It defines as a power series of z, and it also converge. So f of z is well defined in the small open ball region. So basically, f of z is holomorphic. So basically, f of z is correct. F of z is at z equals to a is analytic. So to disprove B, that we try to come up with some example that probably is not correct. Okay, or maybe we can see that. Okay, so suppose so suppose this is f of z, then we try to z plus a, then we have what? Right? Okay, but okay, so you said that this series will converge when z plus a less than 1. Is this correct? So remember that we have z minus a. We have a z minus a smaller than 1 will converge. But now this function is just shift plus a. So we need to transform this equation back to this. So how do we do this? So we can let y equals to we just let y equals to z plus a. So this is 0 y just f of y just from n y minus a to n. Right. But from the beginning we know that okay, so now the convergent this will converge. But y is what? Y is z plus a, right? So this converge with z smaller than 1. Right, because y is z plus a. So now the convergent condition should be z, absolute value of z smaller than 1. Then this is the answer. And in the previous cases, we don't rule out b because we choose a to be 0. So this should be correct condition. Okay, so example is like we can choose. Let me see. Maybe I can choose f of z to be this. So this is 1 over minus 1 minus z. So when z minus 1 is 1. Okay, so then he asked about he want to, so now a is 1. So now he want to ask z plus 1. So this is z plus 1 plus z. This is 1 plus z squared. And then this is the famous 1 minus z. Right? So the condition becomes z smaller than 1. But he said that the power series of z converge for z plus a smaller than 1. Now a is 1. Right? So we have z minus 1. He have z. What he said is z plus 1 minus 1. Less than 1 is the condition. But this is the correct condition. It is false condition. This is the false condition. Because the z plus 1 smaller than 1 is not a condition, but z smaller than 1 is the condition. So use this example, we can show that the B is false. Okay, so the answer is A. The answer is A. So usually complex analysis is difficult in a GRE subject, unless he asks about some integration that you can directly perform. So I hope you guys think it's helpful, and I will see you guys in the final question 66.